In this video, we look at vectors. Now, a vector is a quantity with both magnitude and direction. Vector is pretty simple. As long as you know to count, you can solve vectors. So let's see how fast we can go through this and how easy I can make this understandable. So, how do we represent vectors? It is represented AB with the arrow on top, which shows that it starts at A and ends at B. Starts at A, it moved up to B. It has a magnitude and a specific direction. Okay, so how do you know what direction the vector is going in? Well, this is the north, south, east, west of the Cartesian plane. If a vector is going like this, x will be positive and y will be positive. If the vector is going like this, x will be negative and y will be negative, because you can see that the vector is leaning towards the negative side of the x-axis, but it's going up toward the positive side of the y-axis. This one was leaning towards the positive side of the x-axis and going up to the positive side of the y-axis. This one is going down. It's leaning towards the negative side of x and the negative side of y. This one is going this way, leaning towards the positive side of x and the negative side of y. Now, if you're ever given a vector and you're asked to calculate a vector on the Cartesian plane, this is the formula. Ending point minus starting point. This formula works all over the place, everywhere. You can use this formula to find a vector. That's simple. Okay, now you can use other means as well. So, representing a vector. Vectors is represented using color matrix, the x upon the y. Okay, so whenever you're doing this ending point minus starting point, it will be whatever this x value and y value is minus whatever this x value and y value is. Alright? And you'll have a single x value, y value, as we'll see over here. So, for more information or if you want to check, you can go to page 1021. Good. Now, let's start with the vector AB. Starts at A, ends at B, so it has to be written as A, B, with the arrow on top. Right? And AB is equal to ending point minus starting point, which is the ending point is B minus A. These are the coordinate 5 and 4. So 5 on the x-axis, 4 on the y-axis. Minus A is at 2 and 1. 2 on the x-axis, 1 on the y-axis. So this gives you 5 minus 2 is 3. 4 minus 1 is another 3. So the vector AB is 3, 3. Now, back over here. A vector can be calculated using the ending point minus starting point formula. And also a vector can be observed. No calculation. You can look at a vector and say what it is. This will be the y value, how much distance this vector is covering on the y-axis. This is the x-axis. So you can form a triangle or even a rectangle like that. These are called rectangles, the opposite sides are parallel and equal in length. So this side will equal to that side. The length from here to here will be the x value. The length from here to here on the y-axis or here to here will be the y value. So let's see if we can observe this value here that we got for AB by just looking. And it should be simple. So let's see if we can get the x. It starts at 2 and it ends at 5. So the x value is between these two. If we count 0, 1, 2, 3, we can see that x is in the vector AB, the x value is 3. Let's see the y value. Now, ends at 4, starts at 1. 0, 1, 2, 3. Y value is also 3. See, you can see that there. So I remember this diagram I showed you which one is positive, which one is negative, depending on which direction it's going in. You also have to observe which direction it's going in. Now, this one, go back to this one, it's leading towards a positive side of x, so my x is positive. It's going up, as you can see, so my y is positive. Let's try this one. This one here is leaning towards it's going in that direction. It starts here, it ends here. It starts at E, ends at F. So it's going in this direction. So that has to be a negative x. So let's see what the value is. It starts at 1, it ends at 4. So it starts at -1 and ends at -4. So if it's going in that direction, then it has to be your EF, your x value has to be a -1. So it's a -3. 0, 1, 2, 3. And then we're going to calculate it at the bottom. And your y starts at 0. No, it starts at 4. It starts at 4 and ends at 0. 0 here. So it's 0, 1, 2, 3, 4. And it's going down to the y-axis, going down. So it's negative y2. So the vector EF is -3 and -4. Now let's calculate that using our ending point minus starting point. So EF, this is F minus E, ending point minus starting point. The ending point of F is -4 and 0. The starting point of the vector EF is E, which is -1 and 4. -1 and 4, yes. Good. -1 here, 4 there. X first, Y second. So what does this become? -4 minus -1. -4 minus -1. We know that these two becomes positive, so it is actually 4 minus 4 plus 1. Now when operating on terms with different signs, we subtract the terms and the answer take the sign in the larger term. So this becomes a -3, and 0 minus 4 is -4. Pretty simple. So we get that done. We can observe the vector and we can also calculate it. But in the examination, you will have to calculate it because you have to show some form of working. So I'm leaving these two. This, and I can tell you the answer, but you will have to observe first. Pause the video now. Observe these two, PQ and CD, and then play the video, and then you'll see the answer. But I'll tell you the answer now. PQ is going towards, it starts at P, ends at Q, so it's going towards the positive side of the x-axis. So it has to be positive. This is 0, 1, 2, because it ends at 1, starts at 3, 0, 1, 2. So the x value is going to be 2. PQ is going to be +2. It's going down. It starts at 1, it ends at 4, so it's going to be a -3. And that's how simple as it is. For DC, if we're going from C to D, what am I saying? DC. So CD, let's see. It starts at 5, ends at 1, and it's going towards the negative side of the x-axis, so my x value has to be a -4. It starts at 3, ends at 1, so it's going up for the y-axis, so my y has to be a +2. Now you can do the ending point minus starting point. Alright, so next thing. If you're given vectors like these, a is equal to -3, 6, b is equal to 2, 5, -5, c is equal to 6, 4, and d is equal to -3 and -5, and you're asked to represent that vector on the Cartesian plane. So you have to draw that vector. Alright, you can start a vector anywhere on the Cartesian plane. It doesn't matter where. anywhere on the Cartesian plane, you can start a vector. As long as you observe these signs, you will know, like over here, you will know which direction the vector is going in. So it makes sense to just do a little sketch of this if you have to draw a vector. Alright, so here we go. I'm going to draw the first one. So as you can see, there's no ending point minus starting point here. They didn't give us A, B, or B, C, or whatever. So the vector, the entire vector is A. And I'll show you that, how you just put, where you put A and so on. So this vector A is minus 3 on the x-axis and positive 6 on the y-axis. I can start this vector anywhere on the Cartesian plane. It doesn't matter where. So I'm going to start this vector here at minus 2, at positive 2, and 4. Because it doesn't matter where. So this is my starting point. Now, I'm going to label this vector AB for a specific purpose. Right? So I'm going to show you how the vector should be drawn, and I'm going to show you how to calculate the endpoint. And you need to know how to learn how to calculate the endpoint, because this is a matter for parallelogram, a law of vectors. So if I start my vector here, it has to be negative 3 on the x-axis, so it has to go in this direction, that direction. So if I start here, it has to be at 2, it has to be 0, 1, 2, 3. It has to end at 1. This vector has to end somewhere here at minus 1. And that's how I get my minus 3. I start at 6 at minus 4, and the y value is 6. So it has to be 6 on the y-axis. So it has to be 0, 1, 2, 3, 4, 5, 6. It has to end at 2. So the vector ends there. At minus 1 and 2. And this is the vector A. Let's put the A there. A represent the common letter will represent the entire vector, while the capital AB will represent the ending point and the starting point. Now, let's look at it from the point of AB. If I'm given a vector AB, and I was asked to represent this vector AB on the Cartesian plane, and I said we can start at any point to represent a vector on the Cartesian plane, any point we can start at. And I choose my starting point to be 2 and minus 4. 2 and minus 4. Then AB isn't AB ending point minus starting point. The ending point is B. So this is B minus A is equal to minus 3 and 6. Ending point minus starting point is equal to that. So this vector is equal to this here. So we already have a starting point A. We want to calculate the ending point B. If the starting point A is 2 and minus 4, so B is equal, B 2 minus 4 is equal to minus 3 and 6. So this formula here, this idea, is used to calculate the ending point if you're given the starting point of a vector. So we take over that, and B is equal to minus 3 and 6. That would be plus 2 and minus 4, because when it goes over the equal sign here, it becomes positive. So 3 plus 2 is minus 1, and 6 plus minus 4 is positive 2. So we found the ending point to be minus 1 and positive 2. Minus 1 and positive 2. So if you're given a starting point of a vector, you can easily find the ending point. Okay, so let's do another one quickly, and I'll let you guys do the rest. 2 and minus 5. Positive 2 and minus 5. So x is positive 2. We can start the vector anywhere, and minus 5. So in what direction would this vector going? If x is positive 2, it has to go this way. If it's minus 5, it has to come down. So I can start anyway. Let me start here. Starting my vector at 3 and 3. 3 and 3. X is positive 2, so it has to be 0, 1, 2. If I start at 3, it has to stop at 5 somewhere. It has to stop at 5 somewhere. Y is negative 5. It has to come down from 3 to 0, 0, 1, 2, 3, 4, 5. It has to stop at 2 somewhere. It has to stop there at 2. So this vector has to stop here at 2, at 5 and minus 2. And we can also, this is the vector B. We can also, using this idea here, calculate the ending point of that vector. So the vector, let's call this vector FG. Right? So now FG is equal to, you have to have the arrow at the top. If you don't, it's not a vector. FG is equal to 2 and minus 5. This is the vector. We chose any point for the beginning, for the starting point. So this is the G is the ending point. As you can see, the arrow shows it goes from F to G. So the G minus F is the ending point minus the starting point. And that vector is equal to 2 and minus 5. We chose the starting point for F to be 3 and 3. So G minus 3 and 3, because that's where F is equal to 2 and minus 5 to find the ending point. So G is equal to, when we take over that 3 and 3, it becomes positive because it was negative here. So it becomes 2 minus 5 plus 3 and 3. So G is equal to 2 plus 5 is 5. 2 plus 3 is 5. Minus 5 plus 3 is minus 2. So the ending point G has to be at 5 and minus 2. And you can start anywhere for that. Alright, so you have 2 more to do here. Which takes us to equal vectors. 2 vectors are said to be equal when they have the same magnitude and direction. So we only know when vectors are equal when they have the same magnitude and direction. So how do we know that 2 vectors are equal? If AB is equal to, and it doesn't matter where the vectors are on the Cartesian plane, as long as they have the same magnitude and direction and they're going in the same direction, they are equal. So that is illustrated like this. If you have AB and PQ is equal to 2 and 3, so let me put AB here. I'll start AB at 5 here, and it has to be 2 on the x-axis, so it has to be here. It has to stop here at 2, and if it's here for 3 on the y-axis, if it starts at 1, it has to stop at 4. That will be the 3 on the y-axis, so this vector has to stop here. So this vector AB is going like that. If we draw PQ here, let's draw it from 3. It has to be 2 on the x-axis, so it has to from 3, 0, 1, 2. So it has to stop at 1. I'm going to start it here at minus 3 and minus 1. So it has to stop at 1. So it has to stop somewhere here. It has to be 3 on the y-axis. So if I start here, 0, 1, 2, 3, it has to stop at 2. When you draw these vectors, you can see that these vectors are equal. They have the same magnitude, 2 and 3, and they are going in the same direction, positive, positive. So those vectors are equal vectors. So what's an inverse vectors? Inverse or negative vectors. 2 vectors have the same magnitude, but they are going in different directions. So if the vector was going down like that, the opposite direction, then it will be an inverse or a negative vector. If it were going down, one going up, one going down, the opposite direction. And it's called negative vector because if AB is equal to minus xy, if you want to get the value of AB, you have to get a minus xy. I can show you here. So if it's called negative vectors, right, and AB is a positive 2 and a positive 3, right, and AB, let's say this, the inverse vector was xy. AB is equal to negative xy. So, sorry, xy was a positive one, and AB it will be the negative one. Oh, I have to show you that. Okay. So in this case, let's just this xy will be a negative x, because it's going down and across, and a negative y. In this case, if this were on the Cartesian plane, right? So if you wanted to get AB, it will be minus negative x, negative y. And the two negative, the negative and the negative will be positive, so it will be a positive x. Negative and the negative will be a positive to be a positive y. So we get back our positive AB, because one is the inverse of the other. One is going in the opposite direction, it's negative. So that's how we get in back this. So the negative vectors, they're going in the opposite direction. One is a negative of the other. To get AB, we have to put a negative to xy because they are inverse vector. If you wanted to get xy, it would be a negative AB. All right. So next thing is multiple of a vector, or multiplying a vector. That is simple. You have one vector equal 2 and 3. X and y is equal to 2 and 3, and we put it back on this side again. 4 and 1. Maybe we stop at there, and 4. So let's say xy is this vector x, y, and you multiply by some scale factor 2. It becomes longer. So it'll be 2 times xy, which will be 2 times 2 and 3, which will be 4 and 6 distributive law. So now if you have a vector with 4 and 6, we start it here. 1 and 1. 4, it will have to stop at 5, somewhere there. If you start at 1, it will have to stop at 7, somewhere here. So the vector becomes longer. One is longer than the other one because it was multiplied by some scale factor. Alright, so we'll do another video